Hey friends, good morning. Today is 5th of January 2021 and I thought it's a good time to begin with our earlier discussion on serial data transmission. On the onset, wish you a very happy new year. Today we shall have a word on the transmission medium, which is the cable itself. Its specifications of our concern like the impedance. Most coaxial cables fall in two categories, RG and LMR. The numbers associated with the RG and LMR earlier represented the diameter of the cable, but over the time the numbers have stuck while the diameters have changed. Most LMR cables are 50 ohms, while the RG, which stands for radio guide, have both 50 ohms and 75 ohms cables. Now, the interesting part is why are these two ohmic values for the cables? As we are aware, data and power transmissions employ AC, but when it comes to the appliances and equipment, then we are essentially dealing with the direct current. Force opposing the flow of the DC is basically resistance, which is measured in ohms. However, when it comes to alternating current, we are not measuring only resistance but impedance. We know that the impedance of any transmission line, may it be a coaxial or a twisted pair, is determined by a couple of factors which include resistance, inductance, conductance, and capacitance of the line per unit length. All of these characteristics are influenced by the frequency that is being transmitted. Basically, inductance essentially means the voltages that are induced or created in a circuit from the current's magnetic field. On the other hand, capacitance is essentially the measure of electric charge that is stored in the circuit because of the voltages. Of the two basic type of signals that we use, one is the digital signal, which is a square wave, and other are the analog signals, which are the typical sine waves. Digital transmission is mostly skewed by the capacitance, making the square wave look like a sawtooth or in extreme cases like a straight line. So for a digital transmission to not be skewed, we need a cable with lowest capacitance. Technically, 93 ohm coaxial cable has the lowest capacitance, but it is expensive and so is rare to find. Hence, for a digital transmission, 75 ohm coaxial cable is the closest fit, offering low signal attenuation, relatively low capacitance, and a transmission distance up to 50 feet. So, if we are mobilizing a ROV spread or installing CCTV, a 75 ohm cable has to be run for the digital video, audio, and serial digital interface or the SDI. To put it in our perspective, a RG59 coaxial cable with BNC connectors, or maybe its better counterpart, the RG6 or RG11 with F connectors, are to be used. However, not every case requires only low attenuation. Well, the transmission data require efficient power handling too. So 50 ohm cable is the way to go.